This study is entitled Investigation of the Geomagnetically Induced Currents Development in Mediterranean Countries During the Strongest Magnetic Storms of Solar Cycle 24. I will start with a brief introduction. Geomagnetically induced currents are the ground end of the space weather chain, and as such they constitute an integral part of the space weather research. Traditionally, it was thought that only electricity networks located in high latitudes are affected by geomagnetically induced currents, but similar effects can be observed in lower latitudes such as South Africa as well. In the last decade, an increased research interest regarding geomagnetically induced currents in low and middle latitudes is observed with studies conducted in Italy, Spain, Japan, China, and others, that is, countries with latitudes similar to those of Greece. Geomagnetically induced current indices are calculated for four ground-based magnetic stations in Greece, namely the Enigma magnetometer array, complemented by magnetic observatories in the Mediterranean region, that is Italy, France, Spain, Algeria, and Turkey, around the most intense magnetic storms of solar cycle 24. That is, three storms that occurred in March, June, and December 2015, and one storm that occurred in August 2018. I note here that Zik index is a proxy of the geoelectric field and is estimated straightforwardly from magnetic field data. Here is a map with all the stations from which we have used data, and the Enigma stations specifically are the ones inside the yellow rectangle. We calculate two geomagnetically induced current indices, one corresponding to the north and one corresponding to the east direction, based on the formulas shown here on the left-hand side. In the figures displayed on the right-hand side, we show an example of the Dionysus and HelAS stations for the St. Patrick's Day storm of 2015. Magnetic field time series are shown in gray, the X component in the panels on the left and the Y component in the panels on the right. DST index is also shown in cyan, and the calculated Zik indices are shown in blue. In this example, we observe a correlation between the storm sudden commencement and the maximum Zik X index, and a correlation between the storm sudden commencement and the local increase of the Zik Y index. Here we see the exact timestamps and values of the storm through the minimum DST index, the storm sudden commencement, and the maximum Zik index values, where indeed we observe coincident occurrence at around 4:45 UT. Now to conclude, overall our results show that Zik index values increase with increasing geographic latitude. A correlation between the storm sudden commencement and an increase in the Zik index is observed. During the investigated time intervals, Zik index values did not exceed low activity levels, at least based on the current risk level thresholds. However, the geoelectrical structure of the area that each station is located is not taken into account, and this might seriously affect the development of geomagnetically induced currents. Thank you very much for your attention.